Okay, I am Dr. Shiva, Assistant Professor, Department of Mathematics, St. Joseph Institute of Technology. Today, my lecture is numerical methods, and particularly solving for ordinary differential equation in Euler's method. Right? So, we will move for Euler's method. In this previous lecture, I will discuss with already for Taylor series. This is my second session for Euler's method. Okay, so solving ordinary differential equation to using for numerical methods. So Euler's method. First of all, Euler's method formula is yn plus 1 equal to yn plus hf of xn comma yn. This is a fundamental formula for Euler's method, isn't it? Right. So now I am putting n equal to 0, then only we get y1. So y1 equal to y0 plus hf of x0 comma y0. This is a first formula. Then put n equal to 1, we get y2. So we get y2 means y1 plus hf of x1 comma y1, like that. So dot 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 etc. So put for example, put n equal to 0, we get y1. Put n equal to 1, we get y2. Put n equal to 2, we get y3, like that. Okay. So they are asking find y of 0.1, y of 0.2, y of 0.3 means you have to substitute here, put n equal to 0, put n equal to 1 and put n equal to 3. Okay. Now we will move for the first example number 1. Okay. So example number 1. It's the first problem. Okay. So using Euler's method, solve for y at x equal to 0.1 and x equal to 0.2, right? From the differential equation dy by dx equal to x plus y plus xy, y of 0 equal to 1, then taking h equal to here 0.1. Okay, so anyway they are giving the differential equation is y dash equal to x plus y plus xy, right? So solution given differential equation is y dash equal to x plus y plus xy. This is our given differential equation, right? So then the initial value y of 0 equal to 1, right? So y of 0 equal to 1 means x equal to x not equal to 0 and y not equal to 1. Here they are given x not equal to 0 and y not equal to 1. Then h equal to 0.1 is already given. Okay, so maybe sometimes they are not given for h. Okay, that time we will take, first of all, listen the problem. Here they are asking y at x equal to 0.1 and 0.2, right? Okay, see the difference between these two values, that is a difference. What do you mean by difference, students? So difference means h equal to b minus a. Okay, so b minus a means here they are given 0.1 and 0.2. So h equal to 0.2 minus 0.1, then we get h equal to 0.1, right? So here they are giving the initial values are x not equal to 0 and y not equal to 0, then h equal to 0.1, right? Okay, I hope all are understand this particular problem. Then here they are asking to find y of 0.1. Okay, here they are asking y of 0.1. Okay, fine. So y of 0.1 using Euler's method, right? So put n equal to 0 means y1 y0 plus h f of x0 comma y0, right? Okay, so therefore y1 equal to y0. What's the value of y0 here? See, listen. So y0 equal to 1. So y0 equal to 1, then h equal to 0.1, then f of x0 comma y0. What do you mean by f of x0 comma y0? See, listen. See, y dash equal to dy by dx, all are known. See, this is a function. So therefore here they are given dy by dx is called f of x comma y, right? So this is our function f of x comma y. So therefore we will take the differential equation dy by dx x plus y xy, that is our function f of x comma y, right? So at the same thing here they are asking for f of x naught comma y naught. Now I will replace in terms of x2 x naught and y2 y naught, right? So x naught plus y naught plus x naught y naught, right? Right, good. Then 1 plus 0.1 bracket, what's the value of x naught is 0, y naught is 1, because already find it. So 0 into 1. Finally we get 1.0.1 into 1, we get 1.1. So we get 1.1 is y of 0.1 equal to 1.1. That is our answer. Okay, it's a very simple problem for Euler's method to solve the ordinary differential equation using for numerical methods, right? See, again I will recall this problem, particular problem. See, y dash equal to x plus y xy, right? The same thing here, they are giving the initial values are y of 0 equal to 1. That means this is a x naught equal to 0 and y naught equal to 0, h equal to 0.1, right? So now then we will substitute the formula. Already we know the formula for in general formula. Already we know what's the formula. See, formula is yn plus 1 plus equal to yn plus h f of xn comma yn, right? This is our fundamental formula for Euler's method, right? So put n equal to 0, then only we get y1. Put n equal to 2 means we get y2. So y1 equal to y naught plus h f of x naught comma y naught, and put n equal to 1 means we get y2. So y2 equal to y1 plus h f of x1 comma y1, like that. Okay, these are all the formulas. Okay, so here we will substitute y1 y naught plus h f of x naught comma y naught. So y1 plus h1 plus value of h is 0.1, right? So we have to replace the function f of x comma y. Already here they are given x plus y xy. So in terms of x naught y naught, substitute the value, then only we get the answer. This is a first step, right? Then to find y of 0.2, this is a second subdivision, right? So now to find y2, so already we know the formula, right? So y2 equal to y1 plus h f of x1 comma y1. This is a formula, x1 plus h f of x1 comma y1, right? So therefore what's the value of y1 and the x1? First of all we need x1 and y1, right? So already we get the first subdivision of the value y of 0.1 equal to 1.1, right? All are no? All are understand this values, right? Yes, I hope all are understand this. See, listen. So x1 equal to 0.1 and y1 equal to 1.1. This is the value of x1 equal to 0.1 and y1 equal to 1.1. Then this value you are going to substitute here, right? Then only we get y of 0.2. Dear students, all understand this? Yes, y of 0.2, right? So value of y1 is 1.1 plus value of h is already we know 0.1. Then f of x comma y, what's f of x comma y? Because here they are giving the function f of x comma y here, that is our dy by dx, right? So here they are given x plus y plus xy. So you have to replace in terms of x2 x1 and y2 y1. Okay, so x1 plus y1 x1 y1, right? Very good. Yes, good. So therefore 1.1 0.1 into value of x1 we get 0.1 plus y1 value is 1.1 and 0.1 into 1.1. So close the bracket, then use the scientific calculator. Adding this we get the answer. Not only for addition, here we use for multiplication also, because before is 1.1 is there plus 0.1 into remaining values. First of all you have to add and multiple, then we get the answer, right? So we get the value is 1.1. So 0.1 in the brackets you have to multiple using for scientific calculator, we get some value, then multiple for 0.1, we get the value is 0.131. Okay, 0.131. So finally we are adding y of 0.2 equal to 1.231. This is the final answer of the first problem in Euler's method. Dear students, all are understand this particular problem? Yes. Okay, good, very good. Okay, anyway, we will move for the example number 2, right? Okay. Once again, I want to recall this formula. What's the formula for Euler's method? Euler's method formula is yn plus 1 equal to yn plus hf of xn comma yn. F of xn comma yn is a function. They are giving the ordinary differential equation, right? Then put n equal to 0 and put n equal to 1, we get y1 and y2. That y1, y2 only for y of 0.1 and 0.2. Okay, I hope all are understand. We will move for the example number 2. We will move for the example number 2, right? So our question is, using Euler's method, find y of 0.2, 0.4 and 0.6. Here they are asking for 0.2, 0.4 and 0.6. It's not a simple problem. Okay, first I hope understand. Then from the differential equation, here they are given dy by dx equal to x square plus y. Okay, then y of 0 equal to 1 with h equal to 0.2. With h equal to 0.2, right? Here they are directly given for the difference 0.2, because here they are asking y of 0.2, 0.4 and 0.6. See the difference between these points. So 0.2 and 0.4 means h equal to b minus a, already I said, right? So h equal to 0.4 minus 0.2, we get 0.2 only. See the difference for all the terms, we get h equal to 0.2. At the same time, in this particular problem, they are given directly for h equal to 0.2, right? Now, solution, given dy by dx is a function, right? So here we will take f of x comma y equal to x square plus y. Then initial value y of 0 equal to 1, right? Dear students, all understand this problem? Yes. Yes, good. So x not equal to 0 and y not equal to 1, right? So x not equal to 0 and y not equal to 1 and h equal to 0.2, because here this value is x naught and this value is y naught. Okay, this value is x naught and this value is y naught, right? So then we will use for the formula. First of all, to find y of 0.2, already we know the formula. We know that Euler's method, right? Yn plus 1 equal to yn plus h f of xn comma yn. This is your formula, right? xn comma yn. H f of xn comma yn. Okay, put n equal to 0. So this is the first case, that is called here 0.2, right? So put n equal to 0 means we get y1, y0 plus h into f of x0 comma y0, right? x0 comma y0, right? So this is our y of 0.2. Okay, so already we have y0 is 1 and the value of x difference is 0.2. Then f of x0 comma y0, right? So here the given differential equation dy by dx equal to x square plus y. X square plus y, right? So x square plus y means here we want to replace in terms of x to x0 and y to y0, right? So x0 square plus y0, close the bracket, then substitute the value 0.2, then x0 square is 0, because 0 square is 0 only, all are no, I hope. So 0 plus 1 is 1, so therefore we get 1 plus 0.2 into 1 is also for 0.1. Finally we get y of 0.2 equal to 1.2 only. This is the first subdivision answer. Okay, this is the first subdivision answer. First subdivision answer is y of 0.2 equal to 1.2. 0.2 equal to 1.2, right? Then here we get the value of x1 and y1. Okay, So x1 value is 0.2 and y1 value is 1.2. Here x1 value is 0.2 and y1 value is 1 point. Okay. Then to find next subdivision, okay, to find y of 0.4, right? So y of 0.4. Next to find y of 0.4, here we will use for Euler's method, put n equal to 1, right? Put n equal to 1 means, see, listen, our formula is yn plus 1 equal to yn plus hf of xn comma yn. Now here we will substitute, put n equal to 1, we get y2. So the y2 is here y of 0.4. Okay, put n equal to 2. That means y2 y1 plus hf of okay x1 comma y1, right? So therefore y of 0.4, already we get the value of y1. What's the value of y1? 1.2 plus value of h is h equal to, already we know 0.2, right? So 0.2, then f of x1 and y1. So f of x1 y1, here we will replace in terms of x2 x1 and y2 y1, already we know. So I am putting directly x1 square plus y1. Then substitute the value of x1 and y1. 0.2 close the bracket, x1 square 0.2 the whole square plus y1 is 1.2 close the bracket. Okay, using the scientific calculator we get the answer, right? So first we have to simplify these particular bracket, then multiply by 0.2, then we get the answer, right? I hope all are understand. It's a very simple method. Okay, so 0.248 we get, then adding 1.2 and 0.248 we get the answer 1.448. So this is a answer for 0.4. This is the second subdivision of this particular problem. So y of 0.4 equal to 1.448. This is the answer. Okay, anyway, this is our what? See, listen. Last subdivision we get x1 and y1. Okay, this is the second step. Okay, second stage. So this is our x2 and y2, right? So therefore our x2 is 0.4 and y2 equal to 1.448. 1.448, that is a second values. These are all the values. Then next to find this third subdivision, to find y of 0.6, right? So to find y of 0.6. Okay, anyway, please tell me anyone for the value for the substitution here, put n equal to 0, 1 or 2. Yes, correct. Yes, I hope you understand. So put n equal to 2 only, we get y3. So y3 is here y of 0.6. Put n equal to 2 only, right? Yes, good. So put n equal to 3 means we get y3. See, listen, this is a formula. Put n equal to 2 means we get y3. So y3 equal to y2 plus hf of here xn yn. So put here x2 y2. Put x2 comma y2, right? Good. So this is our formula for y3, right? So now to find y of 0.6. So y of 0.6. So here y2, right? So value of y2 is already we get the second subdivision, previous subdivisions. So here we get 1.448 plus value of h already we know 0.2. Then f of x2 comma y2 means you have to replace in given differential equation here dy by dx equal to x square plus y. That means x2 square plus y2, right? You have to replace x2 and y2. Okay, so x2 square plus y2. So therefore here we will substitute the value 0.2, then x2 is 0.4 the whole square plus y2 is 1.448, right? Then you have to simplify these values, we get the answer. Using for scientific calculator, we get the answer, right? So here 1.448 plus 0.2, close the bracket, you have to use for the calculator, we get some value, okay, we get some value, then we are adding 1.448 plus the value is 1.48 and listen, wait, yes, correct, 0.3216, okay, 0.3216 I am putting for the calculator, then only I am writing here, okay. So we get the final answer is 1.7696. That is the final answer of this problem, 0.6. This is a Euler's method. See here finally in this method, in my conclusion is here they are giving some differential equation with the initial condition, okay, then here they are asking some particular value y of 0.2, y of 0.4 and y of 0.6. that time we will use for Euler's method. That method formula is yn plus 1 equal to yn plus hf of xn comma yn, okay. For example, put n equal to 0 means we get y1, that is our y of 0.2. Put n equal to 1 means we get y2, that is our y of 0.4. Put n equal to 2 means we get y of 0.6, that is our third step, okay. This is a 8 more problem. I hope all are understand this particular problem. It's very useful for all, okay. So all are understand this, then we will move for one more method, okay. One more method is Euler's modified method, okay. So Euler's modified, one more method, Euler's modified method, okay. So Euler's modified method formula is yn plus 1, yn plus hf of xn plus h by 2, comma yn plus h by 2 f of xn comma yn. See the difference between Euler's method to modified Euler's method. So we need some accuracy, right? It's more efficient, more faster to solve the particular differential equation. We get some approximate value, because see, now we are going to solve the differential equation to using for ordinary differential equations means we can't get the exact value. Here we are getting for always for some approximate value only, right? Here they are using so many methods, okay. Yes, in particularly for ordinary differential equation we will solve for single step method and multi-step method. What are the methods are to solve the ordinary differential equation means Taylor series method and Euler's method, modified Euler's method, and one more method is Ranjikutta method, that is called RK method, okay. These are the so many methods are there. One more method is multi-step method, Millin's predicted and corrected method. In particularly in this session we will solve for Euler's method and modified Euler's method, okay. So modified Euler's method means Euler's modified or modified Euler's method, both are same, right? So yn plus 1 equal to yn plus hf of xn plus h by 2 comma yn plus h by 2 f of xn comma yn. This is a fundamental formula for Euler's modified method or modified Euler's method, whatever, okay. In particularly put n equal to 0, put n equal to 1, like that. Put n equal to 0 means we get y1, right? So what's the formula? y0 plus h of x0 plus h by 2 y0 plus h by 2 f of x0 comma y0. This is a formula. Then y2 equal to, put n equal to 1, right? So y1 plus hf of x1 plus h by 2 comma y1 plus h by 2 f of x1 comma y1, close the bracket. This is a formula. These are all the formulas of modified Euler's method, right? Now we will move for the some examples of modified Euler's method, okay. We will do one problem to solve modified Euler's method. Example number 1 is a very simple problem. I will solve here. Solve dy by dx y minus x square plus 1. Okay, then using Euler's modified method, okay, find the value of y of 0.2 with the initial condition y of 0 equal to 0.5. So y of 0.2 comma y of 0.5 is, this is the initial value. Okay, so solve this problem given f of x comma y. Here they are asking for y of 0.2 only. That means put n equal to 0, we get y1. That is our sum, right? So here they are giving the differential equation dy by dx equal to y minus x square plus 1. That is our function f of x comma y. All or no? I hope all are understand, right? Then initial value is y of 0 equal to 0.5. That means x naught equal to 0 and y naught 0.5. Okay, then h equal to, here they are given 0.2, because here they are asking to find y of 0.2, then only we will take the difference h equal to 0.2, right? Here they are asking for only single iteration, not for two iterations. Here they are not asking about y of 0.4, 0.6 like that. Here they are asking for y of 0.2 only, right? Then to solve this problem, y of 0.2. So here f of x comma y equal to y minus x square plus 1 is there. So solve this equation, we get the answer, right? See now I am substituting the formula. Already we know the formula. So put n equal to 0, we get y1, right? Yes, good. So substitute the formula. Y1 equal to y naught plus h f of x naught plus h by 2 comma y naught plus h by 2 f of x naught comma y naught, close the bracket, right? So substitute here the value of 0.5 is y naught plus 0.2 is h, all or no? Then bracket f of value of x naught is here 0 plus h is 0.2 divided by 2, then y naught is 0.5 plus h is 0.2 by 2. F of x naught comma y naught means here they are giving the differential equation. See, y minus x square means we will substitute here y naught minus y naught square plus 1, close the bracket, right, good. Then substitute the value 0.5 plus 0.2 f of, now 0 plus 0.2 divide means 0.1, right? 0.1 we get. Here you have to simplify 0.5 plus 0.1 into, here x naught minus, y naught minus x naught square, right? So value already we know, 0.5 minus 0 plus 1, close the bracket, right? So 0.5 plus 0.2 f of 0.1 comma, so simplify this value, we get 0.65. okay, use the scientific calculator, we get the answer. Is very simple. I hope all are understand. Okay, then we apply again for f of x comma y. Okay, again f of x comma y here. See here they are given 0.2 bracket, right, y minus x square. So value of y is 0.65 minus 0.1 the whole square plus 1, close the bracket. Simplify this step, we get the answer, right? So we get using for scientific calculator, we get the answer 1.64. okay, so then 0.5 plus 0.2 into 1.64. okay, so 0.5 plus 0. Use the calculator, 328. Then we are adding, finally we get y of 0.2 equal to 0.828. 0.828. This is the final answer of modified Euler's method problem. Okay, so again I will recall this particular problem. Okay, see, solve the differential equation using Euler's modified method to find y of 0.2. That is our aim, right? Here the initial values they are given y of 0 equal to 0.5. So value of x not equal to 0 and y not equal to 0.5. See the difference h is 0.2. Then to find y of 0.2. That means put n equal to 0, we get y1. That y1 is called y of 0.2. Okay. Already we know the formula y1 equal to y naught plus h f of x naught plus h by 2 comma y naught plus h by 2 f of x naught comma y naught. Then here we are substitute the value in directly. Okay. So I am substitute the value. We get the answer. Okay, y of 0.2 equal to 0.828, right? This is the final answer of this problem. Anyway, I will solve the session. Thank you all.